Hello, good afternoon everyone. My name is Abhijit Chaudhary. I hold an MS in Mathematics and Computing from IT Guwahati and another MS in Analytics from Georgia Tech. Currently I work with ADP, the market leader in all things payrolls and HR. My today's presentation reflects my own views, and I would like to thank my co-authors, Dr. Abhimanyu Words from FDU, and two talented STEM high school students, Rohan Pupala and Arav Rao. Having said that, let us get started with my today's presentation. So this is a topic which can give you an overview. We all shall agree that today software development has gone through a paradigm shift. Essentially, we shall agree that a lot of code across companies are now AI generated, and this is a new norm. So in today's modern software development, what is the best way to leverage this, the capability of AI code generation tools, so that we ensure that from going from one version of software to the next, we are adding the features and we are also ensuring the backward compatibility of the software. So just to make it interesting, we can take an example. We are in New Jersey, which is here at the bottom. This is our software working all good at time t equal to 0. We are driving on I-87 north going to Albany. Partially somewhere we take a bifurcation, take an exit, and then this is where we start developing a new feature. This is 287, our bypass, and then we need to merge back to I-87 north before reaching Albany. But when we are doing this software development, we need to drive sober, otherwise get pulled over, right? So that sets the stage. When you do software development, you need to build checks and balances, primarily validation mechanisms, automated validation mechanisms, so that you are able to ensure that you are adding the feature, but you are not breaking anything which was working previously. So that is the idea, and for which I am introducing the validation approaches and overall mitigating the related challenges. So this slide gives you an overview that we have a two-pronged approach to ensure this, and I shall be using a particular software, working software, which I have done for this demo, a working software. Okay, let me go and show you that. So this is an example where you can go, this is an URL, you can go and check it. Okay, so it is called this app.foodgent.com. So I couldn't get the URL foodagent.com, that was expensive or not available, but I got foodgent, which is everything except the A word. So what it does is something we can all associate, that is a kind of burger shop, okay, smart bistro, which sells foods, and you or anyone can go log into the user interface. You can chat and you can ask and order food items. Okay, like you can see here. Okay, and you can interact with the system and you can go and order. So now let us go and introduce the topic and go into deep one by one. So I would use this example, this software, as a running example to illustrate whatever I am talking about. So before going into the details, so before going into the slides, I have created slides show and tell one topic at a time. Before going into that, let me give you an overview or a sketch of the key ideas in this slide. So there is a paper from Google, a very landmark paper, which says that there is a lot of hidden technical debt in machine learning systems. Modern software has a large language model or generative AI model at the center, but surrounded by a large infrastructure of codes, support systems, which all work together to implement different functionalities. Now, the machine learning system has their problem of their own. Like Afshin was saying, that there is a model drift and all. And on top of that, all the challenges of traditional software is already there. So, we need to handle the challenges of traditional software and the machine learning software challenges. So, there is a need to have deterministic validations, and there is a need to have probabilistic or LLM validations side by side, developing a hybrid approach to mitigate all the risk associated with the system. And then we present a quick overview of how traditional software develops. And the key idea is that for validating a large language model, we are introducing or we are using LLM-as-a-Judge method. What I said is the software or the working software which I show is basically an agent, food ordering agent, where we have deployed the framework of LangGraph, which has one large language model at the center, and it has different tools related which it can use for implementing different type of functionalities. And as we go into the details one slide at a time, we will see how we are doing the different parts of our work. So having said that, let us go and get started with it. So the first thing is talking about a quick look into it. How really the modern software works is that there is a part which is called machine learning system. Traditionally, we can start with a quick procedural prototype. We want to experiment with one machine learning system. We can just spin maybe a Jupyter notebook, give it the representative data, and we can ascertain, yeah, this is the champion model. And we have proved one thing. So this has been a research flavor which was aimed in certain part, which is still there. But the real value of a machine learning system is only there when it becomes part of a bigger product, where it sits at the center. And when we make it a part of a big product, there are a lot of challenges which is there in the right side of this slide, which I am trying to say. And the key challenge is that of the technical debt. What it means is that if we don't have this kind of validation mechanism and safety nets, release after release, we will be finding different kind of issues. Some will be AI specific, some will be typical to the usual software system, and there would be compounded challenges. And here is the call out. Unless we marry the traditional machine learning or data science discipline with the modern software engineering, we would be dealing with a high interest credit card situation. We have the machine learning system with the change in prompt, with the change in the foundation model version, with the change in the underlying data, the model performance will degrade, part A, and then there will be challenges related to the traditional software, and hence it's very important to build such validation mechanism. So now coming to the traditional software development life cycle. How it works is, like what the example which I gave is, the whole software development is at any time t equal to 0. Suppose today is 8th of May, our team will decide that we have a stable product in deployed on the web, on the cloud, which users are using all around. We want to add a new functionality or feature in this software. So from 8th May to maybe towards the end of May, we give a target, and in that time period, we need to develop that feature, but also we need to do all kind of testings to ensure nothing is breaking which was working previously. That's the traditional software example. And for that, I am using one example of the Smart Bistro, where users are ordering food from a food menu. And what I am depicting, that suppose there were menu items, certain menu items, and I want to add one more food item, like some special kind of sandwich. So to add that, we need to run a kind of validations to ensure that we are not breaking anything which was working previously. So this is the representative example that typically any software is a hierarchy of different codes. Like in my example, this is a restaurant food ordering menu. It has an agent within which there are a lot of modules, files doing specific functionalities, lot of tools and variety of things. And what happens that whenever a development will happen, a developer will be changing only certain files, and we will validate that how the change in that file is agreeable or not. So here is that example, like if it was one single file, we are adding one item in food menu. This was what was already there deployed in the system. We added one new food item, so one human will come here and he will address, yeah, this is fine, this should be added to the software system. And this is how we will take care of addition of food menu. So this is traditional software. But when we talk at a bigger scale, how the part which is powered by large language models, and large language models have a tendency that they are probabilistic in nature. You will give a prompt, it will give you one response. It may give a different response in slight tweak of the prompt, or maybe even in the same prompt. So to deal with those situations, we need to have a different strategy. And this is a key slide which gives us the architecture of the application which I introduced at the very beginning. What it says is that the job of that application is to help users order food from a menu, and when the user type, first the system will understand what user is really trying to ask. If it is unclear, then the large language model, which is like a brain, it has an ability to understand natural languages. It will first try to understand what it is doing. The control will go to the large language model. Once it is sure, then it will call, either go and show the menu and show the user what are the relevant items, and then add to the cart, and then confirm. So I'm just spending a bit of time. This is very basic to really make have your interest pivoted. And having said that, so this is the chat node, which is like a traffic management system. It decides that what really need to go and which user tool should be called. So give me 1 sec and allow me to go and type a prompt here. So what it is saying, see, it welcomes you, and he says that I can help you order food. You can go and you can order from original meals, kids meals, and all those items. Okay, so let me just type a prompt. Okay, I'm saying, give me a sandwich. Just hold on, okay, and say the way people talk, waffle fries. Okay, let us see how it deals with, because this is not a very clear cut. Is the LLM able to handle it? Okay, so see what it happens is, just see, it's saying, just to clarify, which sandwich and waffle fry sizes. So what I'm trying to say, in this moment, the LLM is doing the traffic management. It is deciding which tools it need to call. From the menu, we need to go and find out which one it really needs to find out. Okay, so, and this will make the rest of the presentation easy. And let me just type something more for later use, so that I can just use. Okay, so what I'm trying to say, ultimately, the job of this software is, or in general any software, is to help the user achieve its objective, that of ordering food. That's the ultimate goal. Whatever is inside the hood, whether it is a very fancy agent or whatever, if the software is able to do that job, then it is successful. And that's what I'm trying to say, that whenever we are designing a software, we should design with that end goal in the mind, and should not kind of overload or rely on an LLM and agent. And what that boils down to, that if we have something which we can take a deterministic path, ultimately the user will be served one item from 24 menu items. So why not to split each question and call and deterministically run the algorithm and return what is really there available. That's the ultimate goal, and that's the intent of designing this software. So if we have a deterministic pathway, and then whenever decisioning and this kind of natural language interaction is there, that would be taken part of by LLM. So we should split the whole flow in something which is deterministic. So deterministic input, deterministic output, deterministic input, output, if they are working pairwise, then we are golden. The software is doing its job and nothing is breaking. And then we are left with some part which is not deterministic. Like we can ask a question and there can be varied responses for that, because in natural language we can ask something which can be answered differently, but the semantic is same. So this second part is what is called LLM-based evaluation or LLM-as-a-Judge. So this is something which is practiced in industry. What I'm trying to say is that whenever we are building the software, we will have a large amount of software which is traditional, where we have the traditional flow of things happening. And there is a part which is quite prevalent in modern software, where people interact with your system in natural language. They can ask the same thing but in different wording, and so your backend system, which is LLM, can answer them different language wise, but you need to know whether the different response is still aligned to what the user is asking, and it is not giving something which is different, or it's not hallucinating. So those words, hallucinating, etc., are taken care by this LLM-based validation layer, and there is a structured or empirical approach to do this. And in my paper or in my presentation, I have run different experiments and produced results for this side and this side both, and added tabular outputs in my paper. So what you will say, this part is kind of more interesting, where for the food menu, which I was saying, I give it a golden set of prompts or questions based on which I get answers. Those answers can be differently worded, but those answers are coming from the main agent, which is a Claude 3 model, and another model is there, another LLM is, which is Claude 4.5. So Claude 4.5 will take each of the responses and compare that against a standard golden set and do a validation whether this thing is semantically, meaning wise, correct of what we expect. Based on that, it will give a score. How much good? Is it like 7 out of 10, 8 out of 10, 1 out of 10? And all those numbers has an interpretation. Okay. Based on that, we take a call. The call is whether the new software development is worth adding to the existing software, or if we are adding something which is breaking what was previously working, then we will not add it. That's a key question for the software development team. And that's what the goal we are trying to achieve. So let us go and introduce. So this is kind of my key innovation, that we are dividing the whole task of controlled software development in two parts. One is deterministic, one is stochastic, supported with a real working software, which is a very good representative example, a full-fledged agent which is doing the job of working, ordering food in a miniature version. And these are the key dimensions, like validation nature when we do deterministic. So if we are ordering one crispy chicken sandwich and one sugar tea, then it should only be giving me certain response in language, and the price should match exactly what is there in the menu. Based on that, we built a set of tests which has only deterministic binary pass or fail. In this side, 24 test cases are there. Then for this side of the validation, what we do is that we score the natural language, that how much close this is to what is there in the golden set. And as I said, that there is a judge model which is validating the main model which is powering the agent. And we say that if your score of the judge is greater than 7 and there is not lot of variations across multiple runs of the same question, then we say that it is passing. So basically what we are saying, so this is what I already said, that the whole validation framework is powered by two parts. First engine is structured deterministic testing. So I saw that I have different flows that user can ask a question that give me a sandwich and a waffle fry. So that will ask specific user tools, and those specific user tools are unit of functionality, whether the functionality is working properly. Based on that, we have a structured set of tests which are provided in the paper, and they can only pass or fail. Say if a user in our unified test, whenever we are building the test, we will run a test which will say that give me a crispy chicken sandwich which has a certain price in the menu. So the output, the price when running those tests should match. So we are ensuring that whatever was previously working in the deterministic flow of the software is not breaking due to this addition, and we are good in this part. But then comes the second part, which is here. Excuse me, let me have a sip of water. So here is the thing. This gives us a bird's eye view of what I just presented. There are certain parts, user is interacting in the chat interface. He is asking certain questions, and the system, which is a large language model, is responding in a human-like manner. You just saw the example. Now those responses can vary with slight tweak of wordings. Like I said, give me a sandwich and a waffle fry, right? That's how people talk. So the LLM can respond whether that response was acceptable. Okay, there are different metrics on that. Okay, and based on that, there is another agent. So you can see Abhijit is saying something, somebody else is responding, another human, and there is a third person. Okay, some PhD level person, very intelligent. Okay, so that is the judge LLM. So here I have a Claude 3 and a superior LLM. This is going to evaluate the response given by this person. Okay, so let us see this example. Like here I ask the software that give me a sandwich and a waffle fry. So it asked me, just to clarify, which sandwich, which. So this is like it is making sense. Okay, now I am asking, do you have a gluten-free item or food allergy related item? Good question. Based on your current menu, I don't have specific gluten-free items. Okay, asking the team in store, they can, I'm reading because there is a purpose behind it. Okay, I would recommend asking the team in store. They can tell you about preparation method and cross-contamination, any naturally options we might have. Okay, so this is what it is trying to do. And this example is typical nature of LLMs, where it will not tell you no, but it will try to make up some answer. Okay, and it will try to cut corners. These are the natures of LLM, and we have different words blanketed under hallucination. But hallucination is just a blanket word. There can be a lot of it. There can be fine grains. And that's where LLM-as-a-Judge comes. And we can have specific fine grains to say why this is wrong, why this is acceptable, not acceptable. And let us see how it is playing out. So here what I mean. Okay. So this is a key thing we should pay attention. Catching AI system drift against statistical threshold. So what I was saying, what Afsan was also presenting, that drift in model is always there in nature. So see, this is an example where there are different responses coming from the LLM system, the agentic system. So now we need to score them in different angles, like menu display. you asked about sandwich, did it only show you sandwich related options? If it did, then it is able to help and serve the user its purpose. Order flow, that you said, give me a sandwich and one sweet tea. Did it added those two items one by one and give you the correct price? And its response was exactly what is there in the expected golden set. If so, then we pass it. How do we pass? Not a binary pass, but if semantic meaning of that response as given by the judge is above 70% acceptance, and we run each of the same prompts 3 times, and it should not vary a lot. Okay, the variation should be within the bound of 1.5 sigma 1.5. Then we say that yes, it is giving me meaningful outputs. But the crowning glory is here in this J3. What the software is designed, that everything should come from the menu, and that's what in the welcome screen also, and that makes sense. If there is a question which can't be answered from menu, the judge LLM, the LLM or the agent should clearly say that it should try to help. Okay, what it is trying to ask, suppose I ask the question, do you have some gluten-free items? Okay, so it is adhering to persona. It is an agent, food ordering agent. It's trying to be a food ordering agent. It is humble. Okay, it is interacting nicely, but helpfulness. Okay, if the job of that agent was to help in ordering food, and it is asking that no, you need to go to a store or you need to call, then in the helpness dimension, it is not able to score high. It is not able to help the user. So the software is not doing the job. And number 3, hallucination avoidance. Is it trying to invent something? It is saying that there might be an option or there's something, so it is trying to make out answer. So that thing falls into hallucination. The key takeaway from this thing is that when every day, say 10,000 or 100,000 of people are ordering through that food ordering app, then this behaviors gives up fruits of software not doing its job. And what should be the call? What should be the call to action is here. So whenever there is a taste which is failing in this way, the signal is not about one order of food which Abhijit was ordering or Arman was ordering. Okay, the thing is that the software is not able to help the user. We need to investigate, and in that case, the PR, like whatever we are asking, that we have added this functionality, let us merge it to our software. We will say no, we are not going to add it to software. We will do an automation and we will fail it. Okay, the build will fail because in real world companies, these things are automated. The build will pause and automatically the code will be merged. Okay, and there will be downstream impact. The user delight will be at stake, and then we will fail this build, and then we need to have an action plan. So action plan will be that we will go and look into the menu and we will see, do we have gluten-free specification? That will become a new feature, or we will go and change the prompt and ask the LLM, give it hint that if there are questions related to food allergy or gluten-free advice, then go and look into a frequently asked question document, and we will have to redesign the system. So the whole idea is, this whole mechanism is about tracking needles in a haystack where the system performance can degrade in such systems where the LLM is sitting at the core. So coming towards the end of the presentation, so here is a key idea. Whatever we are building in today in terms of agents, everything is going into traditional software where the leadership is still the same folks who have driven the industry, and they know backward compatibility is non-negotiable. And still the same work of software development is going on, that we need to do a change, we need to do code review, which is basically a diff of which file got changed. One human has to endorse that yes, this is good to go. But we don't ask a human to endorse thousands of files. We need to make his life easier, and that's where this LLM-judge threshold comes in picture, and the dimensions which I said, whether that thing was helpful, whether that thing was hallucination avoidance, those are the metrics which are subject of research and which has pulled my interest, and I have tried to bring in this paper, and I have built an open source food ordering agent to depict the whole idea. So what it is trying to say is CI/CD pipeline, continuous integration, continuous deployment, because we need to keep pushing change in our software to be in the front of the market, adding functionality to the feature, but never compromising in our backward compatibility, and that's why this whole validation framework is of paramount importance. And this is kind of key takeaway. So what I tried to say in all these things, I have grown up as a data scientist, technical data scientist, who also plays with the code. What I'm trying to say, that there is a discipline of software engineering, which is also different from computer science. Okay, there are a lot of things. Software engineering is about ensuring user experience, that you are not breaking anything which was working previously, and you continuously keep on adding features. That's software engineering. That part is still the way it used to be. But now there is a whole big world of large language models and agents, which by nature are stochastic. What stochastics means? They are governed by transition probability matrix, multidimensional. So a small perturbation in the system can lead to different path of convergence, and that is what best seen into a slight perturbation in your prompt can give you different outputs, and whether those outputs qualify in terms of different metrics like helpfulness, completeness, whether the system is able to really help the user is asking. So those things should be embedded in the system, and my take is, we try to make the system as deterministic as possible, so that we are sure that we are not breaking anything. If we are building a food ordering agent, use the LLM, give it system prompts to pick the correct tool so that it does the job, and don't rely too much into the brain of LLM, because at the end it is a stochastic system which will converge differently, and we will have problems. And this is our final bifurcated quality gates, which essentially means those two tables which I was saying, the deterministic results and the stochastic results, and these all are added in the papers. I also had got related review remarks, so everything has been added in the paper, and all the things are there. So that is that, and you can see these are the examples which I tried to sketch my presentation. So yeah, questions? Thank you very much.
Yeah, we have questions from audience.
Questions,
It was
anyone?
nice presentation. It was good? Thank you.
At the
So
same
if you
time,
want to take one group photograph over there, that's fine. Give me some good
Yeah,
behind.
sure.
Yeah.
My pleasure.
Do you want?
Yeah, of course.
If you don't mind.
So you are asking 3 questions to the judge, and then somehow judge calculates the differences between the questions answers, and then you try to somehow identify semantic similarity between answers. How does it work? Workflow in your application?
Yes. Yeah, that's a wonderful question, and that's the crux of my work, and thanks for asking this question. So as you said, so you substantially answer my question yourself when you say semantically compare the answer against what really came in. That's the crux. And what I'm trying to do is, I'm trying to do that thing and in an automated way. What I'm trying to say is, not only 3 questions, I have around 24 or 24 questions which I'm asking as golden set. What it means is, ultimately the job of this software is to help you order food items, okay? And there are approaches based on which you can anticipate that the questions can hit certain part of the software which will become this kind of answers at a high level. So what I'm trying to say, exactly what you said, that something will come as an input to the software will give a natural language output which will, as said, answer, and I need to do a semantic comparison. There are a set of 24 such questions which I ask as a golden set. That is human annotated, okay? That if this is the question, then this is the answer. So what happens in real time? This system can be accessed by thousands of people. Somebody can say that give me a sandwich and waffle fry, okay? That's how people talk. So there is a corresponding golden answer related to that, okay? So the LLM is at the end a very large language model. It has the natural language understanding whether the LLM which is working inside this software, which is Claude 3, is able to, as you shared, semantically meaningful answer is given to the output, okay? So exactly that was my, give me one sec. So as you said that, yeah, so does this answer make a semantic sense? Like somebody is asking this question, yes, this is making a semantic sense. Okay, so it's possible that in those 24 question answer, which I am calling golden set, this kind of thing is already there. And as you said that I am asking the same question 3 times, for the same question 3 times, the same question is asked to the Claude LLM. The responses can vary because it is a stochastic system, and whether the varied responses are semantically very similar or is it a lot of variation. So that is taken care by sigma is 1.5, and scoring 7.0 means acceptable, that it is semantically good. A score of 1 means no, it is very irrelevant, it is trying to make up something, or it is talking something which is meaning wise different. And that's the threshold I'm trying to build.
So just to understand the workflow, for example, we ask, give me a sandwich, okay? And then it generates, behind the scenes, it generates one answer, and then ask another, the same question, generates another answer, ask the same question, generates another answer, and sends them to the judge.
Wonderful.
It's like this?
Yeah, thanks for, no. So how this happens is, there are 2 parts, okay? You asked a wonderful question, okay, and that's how the software should be designed. So let me take you to this slide, okay. So if you see this, you ask that how is the flow. So user asks, then we may have clarifying questions. The design of this particular software is that I'm trying to push that I will pick one particular user to, and I will ask clarifying questions. The way that is defined, the software is defined. But one key thing is that whatever I am talking is not real-time interaction of the user, okay? I need to clarify this. This thing is called taste harness. This thing is run like if I am adding a new item, a new food item, and I am trying to push that thing into the system. I will run this all representative question answer systems and will see that due to addition of that extra code in one of the files, because my software is a large system, okay, maybe thousands of files. I just changed one file, okay. As a human, I will say, I just changed one file. Why on earth I will break something related to food menu? But software doesn't work that way. They want to be very, very stringent. We need to run. So what I'm trying to say, the flow, there are 2 questions which you asked. This is the real-time flow, okay. When a user asks a question, the system will try to get clarity and bring one deterministic path and do the job. This is the flow. But whatever I'm trying to say is the golden set already created, whenever I am going to change my food menu, I need to ensure that everything which is in golden set, which is really an assurance of quality, that whatever is working is not going to break, nothing should break in that.
Okay.
That's the way. And we need to create such questions there, right? Which is not in the menu. And we will fail the system here, okay? Maybe we will fail the system here. This will be an automated trigger, okay? The job is that we will not, what I'm trying to say, that when this thing will fail, the key takeaway will, the software development will not happen. It will stop for one day. Somebody will come and look that, oh, the system is correctly failing because we don't have information regarding gluten food items. We need to create a knowledge repository. We need to enhance the system, build a RAG system, okay? So those are the takeaways, and that's how a modern software development works. This is the way how companies work today, and this is a growing research field. Yeah, that's how I will say.
Okay, thanks.
Thank you.
I have a question.
Yeah.
How do you maintain the golden state?
Yeah, that's a good question. The golden set is like you will create one, and you use the word how do you maintain.
Yeah.
You create one golden set of scenarios in consultation with product and business users who really know the domain, okay? And once you create, but down the line you may discover that there can be a situation where such scenario can come, and at the end of the day, the maintenance of golden set is considerably human driven, because I said that is human annotated. So a human need to maintain that or guide the development of the team, and in practice, development team and business user or product works together to maintain that.
So how do you maintain the qualities of the golden state to cover all the business scenarios, right? You mean like
Yeah, so
that is basically is the most important part.
yes, it is very well taken, and very good question. We devote time in the project, okay? We involve people in traditional, so we have Jira tickets or stories where people work for a few days, and then we keep on running this system and we keep on revising, okay? So it may be possible that our golden set is not representative enough, and golden set helps us in guiding system behavior, okay? Those are kind of standard responses. So a human has to maintain it, and in the software development it is placed somewhere in a particular directory, and we go and change it, and that's how it works.
Have you incorporated any guardrail process in the
Yes, that is also that is also one of the parts, and guardrails are always there, particularly in the prompts, but I intentionally didn't use that word here because this is different from guardrail.
Yeah.
And this thing will give you a feedback that go and add a guardrail unless you don't have a full-fledged system in action.
This is more on application, right?
Yeah, this is more on application, automation, software development. And as I said that if you look, these are very good questions. So yes, software engineering needs automation, okay, because we need things at a scale and where we need to have this kind of engineering. So this is more application engineering flavor, yes.
So, I mean, like, after you build process past all this, do you have like any kind of guardrail process to verify, follow all the guardrail at corporate level before you release? Like security and all this?
So see, the guardrail will fall more on the prompt side, isn't it?
Okay.
So in the system prompt side. So that's a separate topic, but that is always there. Okay, system prompt is always there. And my personal take is that we should design the system in this way that we are going more in the deterministic path. We are able to detect system drifts, but ultimately the prompt is non-negotiable. Okay, we have to do. but eventually those guardrails and prompts are not guaranteed, give or take, right?
Yeah.
We can try due to the stochastic nature. Okay. Yeah. I can say I'm good in prompts, okay, but I know I can't guarantee because this is a transition probability matrix of very high dimension. A small perturbation can just go anywhere. Yeah. I hope I am able to answer. Okay.
Okay. Yeah. Thank you, the speaker.
Thank you very much. This was an interesting topic for me also.